Okay, year 8, welcome to number skills. We are going to officially start our work on number skills today. Okay, number skills involves a whole lot of different stuff, which hopefully the first bit of it should be a revision from year 7. You're welcome to be impressed with my grumpy cat / Little Mermaid picture. I am very funny. You will come to understand. Okay, what we are going to go through today with number skills is order of operations. A very quick revision. However, before we get there, we need to look at factors and multiples, highest common factors and lowest common multiples, and prime and composite numbers. Okay, so 3 main things. Hopefully most of this should be a revision from year 7. Okay, before we begin, a bit of a revision. Factors. What are factors? Factors are whole numbers that divide equally into another, or a whole number that divides equally into another number. No remainder. Okay, so when I'm talking about factors, if I'm looking at factors of 36, 2 is going to be a factor. 3 isn't going to be a factor because 3 doesn't go into 36 evenly. So keep that in mind. Remember that one. Factors. Okay, when we're looking at lowest common multiples, just look at the word. What do we got there? Lowest, smallest. Common, the same. Multiple, multiplication of a number. So if you have a common multiple, you would therefore have to assume it has to be more than one number because you're talking about something common, the same between 2 different things. So a lowest common multiple is a common multiple between 2 or more numbers. And the word lowest here pretty much just means the smallest number that's a multiple of both. It sounds really tricky. I know sometimes I get into exams and I have mental blanks and I think, oh, I don't know what a lowest common multiple is. Think about the words. Lowest, smallest, common, the same, multiple, a multiple of. Okay, let's give you an example down here. Now, this is how I work it out. These will start to become really, really familiar to you, but this is the best way to work it out. We'll do lowest common multiples of 6 and 4. Okay, so they're my 2 numbers, because remember we said 2 or more numbers we have to use to find an LCM of. Okay, let's just do the first few multiples of 6. So, 6 ones are 6. Let's do my 6 times tables. 6 twos are 12. 6 threes are 18. 6 fours are 24. 6 5s are 30. Okay, I think I'm going to leave it there. I'm going to leave it at 30. That'll do. That's just the first few multiples of 6. Okay, let's do my 4 times tables. 4 1s are 4. 4 2s are 8. 4 3s are 12. 4 4s are 16. 4 5s are 20. 4 6s are 24. Okay, cool. I'll leave it there. Now, I've got some common multiples or some multiples that are the same. I've got 24 here. Yep, I got that. That's the same. What else have I got that's the same? Oh, I've got 12 here as well. That's the same. What am I after, however? I'm after the lowest or the smallest number that's a multiple of both. 12 is here. 12 is here. So 24 is a common multiple, but it's not the lowest. So make sure you write it all out. So the lowest common multiple of 6 and 4 is 12. Pretty straightforward. If you'd like a hand doing more examples, come and see me and I'll give you a hand. Highest common factors. Now, highest common factors are a little bit different, okay? So a highest common factor is, again, 2 or more numbers because we have this word common in there, so we make their assumption that there must be 2 or more. And it's the largest number that's a factor of both. Now, rewind. Factors. Whole number that divides equally into another number with no remainder. Okay, got that. So it's a number that goes into another one. Okay, cool. Now I need to find the highest common factor of 2 numbers. I'm going to start you small. Let's start with some small numbers, okay? So we've got 12, we've got 15. Sweet. Factors of 12 and 15. We start from the bottom. 1 goes into 12 evenly. Yeah. 2 goes into 12 evenly. Yep. 3 goes into 12 evenly. Yep. 4 goes into 12 evenly. 5 goes into 12. Oh, no, wait, hold on. 5 goes into 12 twice with 2 remaining. Nah, 5 isn't a factor of 12. Okay, so that must mean 4 is, 6 is, yep. 7, no. 8, no. 9, 10, no. Okay, so my next one is 12. because 12 goes into itself, obviously, once. Okay, let's do 15. 1 goes into 15, yep. 2 goes into 15. Oh, no, that goes into 14. Okay, so it's not 2. 3, yep, 3 goes into 15 5 times. 4, no. 5 goes into 15. 7, no, that doesn't go in evenly. You need 7.5, 8, 9. Okay, so it must be 15. Okay, so what's my highest common factor that goes into both of these? The highest one. Now I've got 2, that's a 1, sorry, that's a common factor. There we go. Okay, whoops, sorry. I've got 1 there and I've got 1 there. That's a common factor. Where else is my common factors? Okay, I've got 3 and 3. Now I'm after the highest one. The highest one that is common between both of them. So if I'm looking at 12 and 15, it's going to be 3 here. When working out lowest common multiples and highest common factors, until you get used to it, writing them out this way is the best way to work them out. Okay, that's lowest common multiples, then highest common factors. What else do we need to know? Prime and composite numbers. These are really, really super easy. And there's just kind of a really simple definition. A prime number has exactly 2 factors, no more. The prime number's 2 factors are 1 and itself. It'll make sense in a second. Composite numbers, over the other hand, are a number other than 1. Can't be 1. 1 doesn't count. And it's any number, it's just not prime. So a number is either prime or it's composite or it's 1. Okay? So, let me give you an example. Now, how the hell do you work out prime numbers from non-prime numbers? Let's do it. Let's say we'll see if we can work out the prime numbers between 11 and 20. So I'm going to write down 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now, we said a prime number has 2 factors. A factor is a whole number that divides equally into another whole number. Now, if we've agreed that prime numbers have 2 factors, 1 in itself, anything that's divisible that 2 can go into can't be a prime number. Okay, so 2 can go into 12, so we're going to cross that guy out. 2 can go into 14, 2 can go into 16, 2 can go into 18, and 2 can go into 20. So I've crossed out everything that must have a factor of 2. Because remember, prime is 1 in itself. So anything that has a factor of 2, it's out. So now I'll write down the factors of 11. Okay, I might just rub this out. I'll just rub out all the ones that I don't want. Oh, it won't let me rub it out. Super duper. Okay, we might go on to a new page then. So I've got 11, 13, 15, 17, and 19. Okay, so these are the numbers that I agree on. Now, let's list the factors of each. Factors of 11. Okay, so 1 goes into 11, 2 doesn't, 3 doesn't, 4 doesn't evenly, 5 doesn't evenly, 6 doesn't evenly, 7, 8. Oh, okay, so it's 1 and 11. Uh-oh, exactly 2 factors, 1 in itself. There's my first prime number. Okay, let's go on to the next one. 13. Yep, 1 goes into 13, 2 no, 3 no, 4 no, 5 no, 6 no, 7 no. Oh, okay, none of those either. Oh, next prime number, 1 and 13. Excellent. Okay, let's do the factors of 15. 1 goes in, yep. 2, no. Oh, 3 does. Automatically means it's not a prime number because 5 does as well and 15 does. So, 15 has more factors than 1 in itself. He's cut from the list. Let's go back. 17. 1 goes into 17. 2 no evenly. 3 no evenly. 4 no evenly. 5 no. Nuts. 17, boom, next prime number. 19, 1 goes in, 2 no, 3 no, 4 no, 5 no, 6 doesn't go evenly. 19, boom, third prime number. See the way I'm talking? I'm working it out in my head and I'm speaking out loud. So 11, 13, 17, and 19. They are my prime numbers between 11 and 20. Okie dokie, let's go. Let's have a look at what else we need to know for today. Order of operations. You guys will be super used to this. Brackets. Whoops, I just drew that in there. Didn't mean to at all. Brackets is my B. Orders is my O. Division, multiplication, addition, and subtraction. Now, you might have learnt O as of, okay? That's fine. What I'm saying when I'm saying orders is square roots and to the power of, okay? So anything that has a square root and to the power of is an order, and that has to come before division and multiplication. So if you need to write that down when we do our graffiti wall, that will be a good idea. Let's have a look at a few examples that we can do. So rather than me just giving you this straight away, we're going to do 1 or 2 examples just to jog your memory. So if I had this one here, for example, if I had brackets 36 minus 23, brackets again, multiplied by 2. BODMAS tells me the order in which I have to do things. Now, when we read a book, we read left to right. When we begin anything, we start from the left and move our way to the right. Just in BODMAS, we start on the left and move our way towards the right. So the first thing I have to do is what's inside the brackets. Now, 36 minus 23, that's 30 minus 20 is 10. 6 minus 3 is 13. So if I work that out, that will be a difference of 13. Okay, now I've worked out what's in the brackets. I can keep the brackets there if I want. That tends to be a good way to do it. Remain consistent. And then it's 13 multiplied by 2, 26. I do the brackets first, and then I do my multiplication. I work left to right because it's brackets, orders, division, multiplication, addition, subtraction. Okay, let's have a look at another example. I'm going to get one that's a little bit more tricky. Okay, what else can we do here? Let's try 28 divided by 4 plus 9. Okay, let's go BODMAS. Brackets, got any? No. Orders, got any? No. Division, I do have some division. So I have 28 divided by 4. I've got my division sign here. I look to see what's on the left of it. 28. I look to see what's on the right of it. 4. They're both positive numbers. So a positive divided by a positive is still a positive number. So 28 divided by 4, that would be 7 plus 9, because that's what I have remaining. 7 plus 9, 16. Okay? Very straightforward, guys. Okay, one more example. Ooh, let's do a really tricky one. 8 plus 16 multiplied by 3 minus 5 plus 45 divided by 9. Whoa! Holy moly, that looks really big. Guess what? Each and every one of you will be able to do it. So, we start from the left and move our way to the right. Brackets. Do we have any? Nah. Cool. Okay, what's the next one? Orders. Do we have any orders? Any square roots or to the power ofs? Nah, don't have any of those. Brackets, orders, division. Do we have any division? Okay. Let's start from the left, move our way. Oh, look, here I've got one here. I've got my division sign here. I look to the left of it. I've got positive 45. I look to the right of it. I've got positive 9. So I know that equals 5. So I rewrite the line the same. 8 plus 16 multiplied by 3 minus 5 plus 5. Okay, perfect. That's my division done. What's next? Multiplication. I start on the left here and move my way to the right. So, multiplication. Oop, here we go. I've got one just in here. Here's my multiplication sign. I look to the left of it. I've got positive 16. I look to the right of it. I've got positive 3. So, I write it out again. 8 plus. Now, 16 multiplied by 3 gives me 48 minus 5 plus 5. So what I'm doing here when I'm doing every line is I'm only making the modification to where I perform the operation. I'm leaving everything else the same that I've already done. So that's multiplication. Now I do addition. I move left to right. So 8 plus 48. That gives me 56 minus 5 plus 5. So minus 5 plus 5. If I look at my number line, I go to negative 5 and I add 5 equals 0. 56 is my answer because negative 5 plus 5 cancels each other out. And that's it, guys. That is the trickiest order of operations that you will get. If you get that one, you're going splendid. If you don't fret just yet. It's just an example there to help you.